Hi, this is Vignesh from Advanced Quality Center. Now we are going to discuss about liquid penetrant testing. It is also sometimes called as penetrant testing or dye penetrant testing. So liquid penetrant testing is one of the effective methods for surface defect detection. It can be used on metals, non-metals, plastics, ceramics, or glasses. But it is not suitable for material with porous surface, such as wood, bricks, or concrete, and also other non-graded castings, such as cast irons with large grain structures. The qualification for the person performing the liquid penetrant testing: he should have clear near vision test and color blindness test. And these vision tests should be performed annually by the employer. The basic principle for liquid penetrant testing is capillary action and blotting action. Capillary action is the action by which the low surface tension fluid penetrates into the crack by absorption of the liquid in the dry wall surfaces of the crack. And blotting action is the action by which the penetrated dye is sucked back by the dry powder called developer. The general steps for liquid penetrant testing are pre-cleaning, application of penetrant, the dwell time for penetrant, excess penetrant removal, application of developer, developing time, indications, interpretation, reporting, and post-cleaning. Pre-cleaning is one of the critical steps for liquid penetrant testing because any dust, grease, oil, chemical, metallic or non-metallic inclusions can mask the defect. The major types of cleanings are solvent cleaning, chemical cleaning, and mechanical cleaning. Solvent cleaning are further subdivided into simple wiping, vapor degreasing, ultrasonic cleaning, or steam cleaning. Chemical cleaning are subdivided into acid cleaning, alkaline cleaning, and detergent cleaning. Mechanical cleaning involves either grinding, blasting, buffing, sanding, machining, brushing, scraper, chisel, or cleaning by any deburring tools. The penetrant used are low viscous and highly penetrating liquid and also should be easily washable. Types of penetrant. Based on the visibility of inspection, the penetrant are classified into two types: type 1 fluorescent and type 2 visible penetrant. Based on the excess penetrant removal method, penetrants are classified into method A, method B, method C, and method D. Method A being water washable, method B being post-emulsifiable lipophilic, method C being solvent removal, and method D post-emulsifiable hydrophilic. Based on the sensitivity of inspection, Penetrants are classified into level half, level 1, level 2, level 3, and level 4. Level half being ultra low sensitivity and level 4 being ultra high sensitivity. Other classifications. The removers are classified into class 1 halogenated, i.e. non-flammable, and class 2 non-halogenated, being flammable. Classification of developers. Developers are classified based on the form of availability. Form A, dry powder. Form B, water soluble. Form C, water suspendable. Form D and E being solvent based, fluorescent, and solvent based, visible, respectively. Step 2. Application of penetrant. Penetrant may be applied by any of the mentioned methods: brushing, spraying, dipping, flowing, or any other means. Before application of penetrant, the surface temperature of the inspection component should be noted. It should be between 10 degrees Celsius to 51 degrees Celsius. For inspection of components other than the mentioned temperature should have a special procedure, and the preparation of procedure is mentioned in Appendix 3 of ASME Section 5 and Article 6. After penetrant application, sufficient dwell time is given for the penetrant to penetrate into the defect. Dwell time varies from 5 to 10 minutes depending upon the material and product form. Few specifications often requires even up to 30 minutes. Given here are photos of penetrant application. Spray cans, spray of large areas, brushing, dipping, the dwell time as per ASME Section 5, Article 6 is given in the table T672. Step 3. Removal of excess penetrant. After sufficient dwell time, excess penetrant on the surface should be removed by any appropriate method. Care should be taken that penetrant inside the defect is not removed. The maximum water pressure for water washable method is 50 psi, and the temperature of water maximum allowed is 43 degrees Celsius. Washing is not done more than 2 minutes in water washable method. In solvent removal method, solvent is not poured directly on the surface. Instead, penetrant is wiped off with lint-free cloth dipped in solvent. For water washable and post-emulsifying technique, drying is done by blotting or blowing dry air, or sometimes using a heating furnace. Pictures of excess penetrant removal are given here. Wiping, emulsification, water washing. Water washing can be done by water guns, either water spray or water air spray. Step 4. Developing. Apply suitable developer to the surface, wet developer for visible penetrant, dry or wet developer for fluorescent penetrant. Remember, apply developer immediately after excess penetrant removal. For suspended developer, shake well before use. Developer application may be by dipping, brushing, spraying, or any other means. Sufficient time is given for drying. Indications appear with time due to bleed out. Few pictures of developer application is given here. Aerosol can spray, spray gun, electrostatic spray, or dry powder application. Also, manual or automatic penetrant testing lines are available. A picture of such working station for liquid penetrant testing is given here. Interpretation. After developing time, interpretation is made. And interpretation should be done between 10 to 60 minutes after developer application. Remember, for visible inspection, a minimum light intensity of 100-foot candles or 1000 lux is required for examination surface. For fluorescent inspection, a minimum black light intensity of 1000 micron watt per centimeter square is required. For fluorescent inspection, the examiner should be in the dark room 5 minutes prior to examination. The indication which appears are evaluated as per the referencing code, such as APA 1104, ASME B31.1, ASME B31.3, or ASME Section 8, AWSD 1.1, etc. There are also reference photographs for type and level of indications in ASTM standard, ASTM E433. Few examples of acceptance criteria from the mentioned standards are given here. We are to the end of the session. I shall share the PowerPoint presentation explained here in the description. Please click the link in the description to download the PDF. Thank you.